So our video today is going to quickly wrap up the discussion we started in class today with regards to identifying of the infinitely many points that exist on a line, two very specific and useful points known as intercepts. Now don't forget, the intercepts are where a graph line cross either at the x-axis or at the y-axis. In the case of the x-intercept is the point at which a line crosses the x-axis. And it's going to show up as an ordered pair that has some given value of x, but it's guaranteed to have 0 for our y-coordinate. Likewise, the y-intercept is the point. Again, it's a point at which the graphed line crosses the y-axis. Its ordered pair will be an x-coordinate of 0 guaranteed with some y value to go along with it. Okay, so don't forget, that's just a quick reminder of how we see an x-intercept constructed and where it's located on the coordinate plane, and how a y-intercept is constructed and where it is plotted on the coordinate plane. So what we're going to do now is take that knowledge, solve for those 2 points, plot those 2 points, and ultimately graph the line that results, because we really only need 2 points to graph any given line. So if we can focus on these 2 points in particular, where the line will cross the x and the y axis accordingly, then it will make the math pretty easy, because we're calculating with 0 in our solving, either 0 for x or 0 for y. But likewise, we're plotting the minimum 2 points that we need to go ahead and graph our line. So let's start with the x-intercept. Remember, the x-intercept says that we need to substitute 0 in for y. So as I start to write this equation out, I'm going to have 8x, whoops, there goes my screen. I'm going to go 8x. Let's get rid of this. So we'll go 8x minus 4. And don't forget, we're going to put 0 in for y equals 24. This is going to naturally cancel out because anything times 0 is 0. So now I get 8x equals 24. And to solve for x, I just simply divide by 8 and I get x equals 3. And don't forget, that's going to be an ordered pair. Because of the fact that I put 0 in for y, I got 3 for x. So we can go ahead and repeat that process this time for the y-intercept. So we're going to start with our equation again, but this time, don't forget, to solve for the y-intercept, we substitute 0 in for x. So 8 times 0, finish writing the rest of the equation, minus 4y equals 24. Once again, anything times 0 cancels. Now be careful with this equation. You're still going to have negative 4y equals 24. Finish solving here naturally by dividing by negative 4. And I get y equals negative 6. That as an ordered pair, as we know, was a result of substituting 0 in for x and getting negative 6 out for y. So now I have everything I need. I have one point here where I'll plot on the x-axis. Don't forget, this is our x-intercept, so that's going to be on the x-axis. I have my y-intercept, which I'm going to plot on the y-axis. And then I'm just going to go ahead and set up my ruler and graph my line. So let's do it. So let's see, the x-intercept, 3, 0, 3 to the right of the origin, 0 up or down because it's an x-intercept. And then likewise, for the y-intercept, I'm going to have 0, neither right or left, but 6 down, just at the edge of where I can be on this coordinate plane. And then you're going to set up your ruler. I'm going to draw my line freehand. I'm going to pass through those 2 points, and I'm going to have my graph line. And that's it. It's that simple. So you're going to repeat this process for the next equation. Now be careful, there's some fractions here, so just make sure you use your operations accordingly with 2/3 when you solve for x and when you solve for y. But you should be able to get 2 points that by design will be able to fit on this coordinate plane as your x-intercept and your y-intercept. From those 2 points, you'll graph your line. So that's all that I will ask you to do, and we'll have more review when we come back to class.